Hey guys, welcome back. Today we are going to solve a problem from operations management, and this is from the simulation chapter. Okay, and I have picked one problem also from June 2024, sorry, December 2024, and we'll just get a glimpse out of this concept and just and straight away go to the problem. Okay, you will easily understand. So that's simple, a very easy problem only, easy concept also. So what does this simulation means? Simulation means at times we could not able to bear the actual cost of testing something. So actual cost of testing something is cost us more, and that would be a big burden. At the time, what we do, no, we do the real life real life scenarios in the simulation product. See, this is like replicating the real life scenarios in the testing phase, the prototype phase. No, what if the scenarios will happen? No, that we are doing with the problems. Okay, so that's what the simulation is. What we are doing here is the real life scenarios we are working out in the problems. Okay, so what kind of real life scenarios we'll test here? So we will be testing the queuing simulations, like how much customer time I have four counters, how much customers so 10 customers are walking, and how much time they'll be waiting. And for system idle time, if it is a manufacturing unit, how much will be the system idle time if there is a strike, or if there is a strike, or the workers are taking a long break. So like this, inventories we can simulate for the reorder level, and the production line simulation we can happen for breakdown time. How much would be the breakdown time, and machine service. See, these kind of scenarios are very costlier very costlier to test in real lives. So we are in statistics, we have a simulation concept there where we can easily test these uncertain situations with the concepts given here. Monte Carlo also like this. Uncertain events, all these are uncertain. All these are we can surely predict. That's how these things will be. So there will be a lot of fluctuation and very volatile situations only come here. So uncertain event simulations, like profit for a next 5 months, profit for a business of next 5 months. So that we can find out with the Monte Carlo simulation. So these are the four methods majorly using in this, and we are using random numbers in this concept. What does it mean? What does it mean by these random numbers? See, the situations, events are very uncertain when it comes to the situations. We are trying it out in this manner, in this simulation part. Okay, so for example, if I'm having four counters and 10 customers are walking, I don't know when they'll come, at what time they'll come at visit the bank. So right at the time, what I'll do, I'll take the random numbers to test the customer walk-ins. I know the 10 customer will come, so I'll take a random time. Okay, so one people is coming at 10, one people is coming at 10, 10:20, one guy is coming at 10:30. So I am taking a random number of even and a random number of time. That's a random number. Okay, to test this simulation, to perfectly work out the simulation, right? That's the random number usages. Random number is, so we don't know the actual time that will happen. Random numbers with no specific pattern used to simulate the uncertain events are chance based. So customer arrival time, service time, demand for a product, when the demand for the product will happen, we don't know, but we somewhere predict, but we don't know the actual time, right? Breakdown time, we don't know the breakdown time. We don't know, we can understand, we can only know the maintenance time. So for this up to this schedule, we should run the machine, and after that we should maintain the machine. So but breakdown time is uncertain event, right? So not fixed. So it's these things are randomly happen, so we are picking the random numbers here. So this is the concept. Just I'll just take you immediately with the problem itself. Hometown Interior Decoration Limited uses a costly dryer while painting the fire protection. Okay, while painting the fire protection doors, they are using the costly dryer. Dryer means something that makes it dry. Okay, so the dryer is highly volatile. So they're highly volatile and it can't be stored. In order to meet the requirement of the dryer, the exact quantity is purchased every day and consumed. Okay, what they are saying is they can't purchase the dryer like 10 units come, 10 units will buy today and will store it and will use it. This won't be like that. So it's highly volatile and it's easy, and it can't be stored. So they have to find out the average demand of the everyday usage to to fix it, to fix with that average demand only. Because if they store, they'll waste the they'll end up with wasting the product, right, wasting the raw material. So the management wants to simulate the demand of the dryer. For this, the management of the company collected data for the past 100 days and application of dryer on the number of doors. Okay, they have collected, and all they have actually collected the past collected the data of how it's applying the real life situation. With this, we are going to find out the average demand. So they have given the daily demand and number of days, and they have also given the random number. See, so random numbers have been given. Random number denotes what? Requirement of this dryer, no, requirement of this dryer or demand of this dryer at a different days. So we are taking a random numbers. So using the following generated random numbers in sequence, generate the demand of dryers for next 10 days and assess the average demand for the dryer per day. So let's quickly prepare the table. Step 1, statement of random number range. Right, so what's the demand we have and what's the probability? Probability here is the number of days. Cumulative probability up to the certain level, how much is the probability. So that's what the cumulative probability is. Then another probability, so it's up to certain level, what's the probability, that's what this cumulative probability means. And then we have the random number range we are going to create, right? Okay, so there is no demand 1 2 3 4 5 6. What's the probability? Probability is 20 by 100, which is 0.2, 0.3, 0.2, 0.1, 0.06, 0.04 and 0.1. So we found the probability. What's the cumulative probability? Add. So you will get the thing, which is 0.2, 0.5, 0.7, 0.8, 0.86, 0.90 and 1. We got the probability 1 achieved. So what's the random number range here? 0 to 19 is the random number range. See how the 0 to 19 has been occurred here. So this is the cumulative probability sequence. So for 0.2 is nothing but the 20. So 0 to 20 probability. So 0 to 19 we have to take up to 20. So take the 19 till the 19 value we have to take, and 20 to 49, 50 to 69, 70 to 79, 80 to 86, sorry it's 85, 86 to 89, then 90 to 99. So we have got the random number range also. So we have this is how we have to build the random number range. So I hope you guys have understood. See 0 to 19, 20 to 49. So this is how it's building. So this is the gap what they have. No, this is our random number range. Okay, right. The step 2 is we have to find out the demand for a dryer. Okay, right. What they've asked us to find out is using the following generated random numbers. So this is the random numbers we have developed. No, yes, you can generate the demand of dryers for next 10 days. They asked us to find out the demand for next 10 days. No, 1 2 3 4 5 6 7 8 9 10. then there is a random number given in the question, no? So we are going to pick the values of random number given in the question. 0 3 23, 36, 93, 69, 43, 87, 51, 11, then so we got the random numbers, but here we have to find out the random number range, not the random number range. Using this random number, we are going to check where the random numbers are actually falling in this category. So 0 3 is falling in 1, the demand for that is 0, right? 23 falls between 22 to 49, the demand for that is 1. 36 also falls between 20 to 49, which is demand for that is 1. And 93 falls between 90 to 99, which is 6. 69 falls between 50 to 69, which is 2. 43 falls between 20 to 49, which is 1. 87 falls between 86 to 89, which is 5. 51 falls between 50 to 69, which is 2. Demand for that is 2. Then 11 falls between 0 to 19, which is the demand is 0. Then 8 falls between 0 to 19, which is 0. No, let's total this. 1 plus 1 plus 6 plus 2 plus 1 plus 5 plus 2 plus 18. 18 is the overall demand. So we have to find out the average demand, no? So 18 divisible by 10, the average demand is 1.8 is the average demand. That's it. The problem is over.